That's why
We are.
see, you get the little live bubble, and there we are.
We are. Hello, everybody. We just went live, and we are going to give people time to join.
What time is it for you, Rory?
It is 5 p.m. So not too late.
Get the both ends of the day right now. I'm 9 a.m. You have 5. Perfect. Anyone that's joining, let us know what time it is for you. Let's see. Where is the comments?
Top right.
There you go. Yeah. Christian, we hope to keep it interesting. Yes. So thanks for coming. EDT sounds like a music genre, not a time. That's like a sweet. We're getting people all over the place. Thanks for coming. I can't keep up with them. We got a lot of 6 p.m.s though. This is great.
We do.
Thanks everyone for coming.
Wow, 9 p.m. in Romania. I had no idea it was so far away from you, Rory.
Yeah, it's a decent distance ahead.
Oh, we got a mountain time zone.
Romania.
Hey, mountain time zone.
Oh yeah. There you go.
Yeah. Where in the mountain time zone are you, Brandon? I'm in the mountain time zone too, Durango.
Uh-oh. We got Victor fact checked himself. 7 p.m.
Oh, up in Denver. There you go.
Yeah, there you go. Denver.
I grew up in Denver. Won't live there now. Okay, let's see. What time are we? 10:01. Do we want to go ahead and get started? Give it another minute. What do you think?
Looks like we got almost 40 people here. We're good. I think this is
great. Okay. Well, welcome everybody. We put together this webinar. We were talking about it, Justin, Rory, and I. And I like to say, so argue with me offline, that Kubernetes is not secure by default, and that the stringent security controls that are needed to protect across bare metal and edge environments, they just aren't there. But there are things that you can do in your environments to help make your Kubernetes infrastructures more secure. So that's where we brought together, I shouldn't say I, because we did this together. We brought together Justin and Rory, both experts in Kubernetes and in security, to talk about this today. So let's do some short introductions. We're going to start with Justin. Oh, I'm Kim McMahon. Sorry, I'm head of marketing at Cedero. And I will be your host today. Justin.
Yeah, I'm Justin Garrison. I'm head of product at Cedero. If you have been following Cedero at all and haven't seen my face, I'm sorry. I should probably make more content.
Okay, well, I'm going to echo the more content. No, I'm kidding. And Rory.
Hey, everyone. So I'm Rory. I'm a senior security researcher and advocate for Datadog.
Thank you. Thank you all for joining. So let's go ahead and just kick off with the first question. Is Kubernetes secure?
Will I start?
Go ahead,
Rory. I can give the traditional security person's answer to that, which is it depends. I always start a lot of my talks with, you can't really say that about Kubernetes because there are 150 plus distributions at this point, I want to say, and every single one of them has a different view on their defaults, on how they set it up, on the add-ons they add, and the way they configure things. And so really you have to think about that. And then you have to think about your threat model. What are the things you're actually worried about? Some people will try and do very high risk, high threat things in Kubernetes, and then they probably have more of a hard time. Other people, maybe less so, and it's easier for them.
Yeah, I mean, I take the approach that it really does depend on your use case. Like, is my house secure? I was like, well, it's secure enough based on location and the door locks I have. But if I want to break into my house, I'm able to. So it's not that secure because I'm not an expert at breaking into a house, but I can get in if I needed to. But also at the fundamental layer, like Linux by default isn't always set up securely for broad internet's public facing sort of use cases. So there's a lot of things you typically have to do to quote unquote secure something for your use case, whether that's adding door locks or just various configuration that is going to be used in your use case, firewalls, whatever it may be, right? That's all stuff that needs to be best practices, because by defaults, most of Linux and Kubernetes is general purpose with no known state of like how you're going to use it and where you're going to use it.
I mean, I think if you look at the Kubernetes project, I always say it was designed with flexibility in mind. It was designed to be very flexible by a diverse group of people from different companies who wanted to use it for different things. And that flexibility is great because it means you can customize it, but it's dangerous as well because it means the defaults tend to be quite open, tend to be quite permissive. Let's get things working. And it is really on people who are using it to actually like bring that down and lock it in and saying, actually, I know what I'm worried about, and I can change those settings to suit my use case.
And by limiting the use cases, you can add security. Is that right?
Yeah.
So are you saying that, just if you go in with a base Kubernetes, you have to figure out how you're going to use it and then figure out what security you're going to add onto that?
Yeah, I mean, definitely. I mean, I take a good example for me in Kubernetes. One of the things that Kubernetes doesn't do for you is it doesn't do authentication, or it does, but the Kubernetes project itself will say the inbuilt authentication mechanisms that come with Kubernetes are not suitable for production use. They're not designed for that, and that's deliberate. But if people are coming from a world where that's not the way they expect to come out of the box and everything's ready to go, that might not be the case, depending on the distribution you're using. You might need to add additional software on, so you might need to think about that, and that carries on through lots of different parts of security in Kubernetes.
Oh, that's
and you see that played out in the products, right? Like, because if you look at something like OpenShift, right, it comes with a more production grade authentication system because it's tied into the Red Hat environment of how are we going to authenticate users to this. And we at Sidero, like, obviously we limit the use cases of Talos. We very much lock down Talos Linux by saying it's only to be used with Kubernetes and only to be used with Kubernetes that we are setting up and configuring. So we know the use case for it. So it's not a general purpose Linux distribution. It is a single purpose. You should use it for this thing. And then from that, integrating up the stack of saying, okay, what is the ideal way to use this in a production like environment? And that's we built Omni for, which has that more production grade authentication side of it. So yeah, exactly. As you go up the stack, you have to figure out what's the use case and how does it integrate into the other things.
Yeah, I do think the stack point's a really important one, because I do a fair number of talks and trainings around Kubernetes security, and I always say it's just layers, and you're building up all these layers one after another, and it's all about all of the layers. And you've got your OS, you've got your kernel, then you've got the container runtime, then you've got probably Kubernetes, and then you've got things on top of that as well and around it. And you need to think about all of those layers because it's very easy to miss one and for something bad to happen.
And in software, like in applications, we always say you can't bolt on security, right? Like security can't be an afterthought because it's not going to end up being as secure as if you built it in from the beginning. And yet pretty much every Linux distro out there, you run security agents to like verify and to more secure, the OS, because you're like, oh, this OS didn't have security in mind from the beginning. So we're just going to bolt on a bunch of agents and things to add security to it after the fact. And most of that's reactionary security, right? It's looking at what might happen or being able to audit what's going on. But very few of them will harden the underlying Linux kernel or the runtime.
Yeah, it's difficult. And weirdly, actually, I almost think that in a lot of ways you can kind of parallel Linux and Kubernetes. And say Linux is a very flexible thing. It can be used for lots of different purposes, and as a result, it can be quite open when you get out of the box. Kubernetes is similar. It's flexible. You don't use basic Kubernetes. Very few people will download like Kubernetes off GitHub and then compile it themselves. Mainly, you're going to use a distribution. So like Linux, you don't compile the kernel. You can, but people don't. And they're both very flexible systems. It is on the operator to actually fix them and secure them.
So you two had you mentioned a couple times in the very beginning the use cases. So, but you haven't really, and you mentioned one, the authentication use case. But I think kind of helping people understand what you mean by use case. When I think use case, I think, oh, I'm using it in the edge, or I'm using it for this type of an application. So maybe giving people a couple examples of use cases and how to secure them could be helpful.
So yeah, the way I tend to think about that is almost threat models. So say, what is my threat model? So for example, say I've got a cluster with some 5 or 6 applications run by one team. Things like authentication are probably less important because the team are a unit everyone using the cluster is probably in that team. Therefore, that's maybe less important. In a threat model where, for example, I've got 500 applications running from a whole load of different teams, suddenly segregation, tenancy, all these things become much more important. And then you get the extreme, which I do know some people try and do. I personally don't think it's an interesting idea, is hard multi-tenancy. So I'm going to have people I don't trust coming in and deploying things and running code on my clusters. And I know that companies do that. And then everything becomes far more serious because you've got people who actively going to try and break your controls. So it's that kind of threat modeling and thinking, right, what am I trying to do here? And then that leads to how much attention do I have to pay to all of the different parts of Kubernetes, and how much locking down do I need to do, and how much, how worried am I about people trying to break all of the various parts? So that's how I tend to go with it.
I think a lot of that comes down to like trust and risk, right? Is how much do you trust the people that are interfacing with your clusters? If I have a cluster here in my home lab and I'm the only one that talks to it, it doesn't matter if I have a static, secret certificate to talk to it. It's only on my network, and I have some level of trust on how it's being used and who has access to it. If I open that up to the internet and then say, hey, look, these workloads that are working on my cluster, I now need to trust those people that are interacting with it, either as a user of the cluster directly or of the workloads, and also of who's deploying applications. If I open it up to say anyone can also now deploy workloads, now it's another trust issue of like, okay, who actually is doing what to my cluster? Where do I need to harden things? And what kind of risk is involved there? If I'm keeping payment data in my cluster and all of a sudden I let anyone deploy to it, I'm like, actually, maybe that risk is too much for me to just open up. And it's the same way with like physical things. Again, it's like my wallet, has a credit card in it, and I don't put the credit card number on the internet because I don't, it's a secret that I need to secure at some level because there's a risk behind it. And even when I have my wallet, I don't leave it out on tables, and I don't leave it like it's in my pocket. And so I make sure that those sorts of things are secured in ways that I know how to secure them based on the risk involved. And Kubernetes and Linux are very similar, where depending on what you're doing and where you're doing it, it really matters on how much you have to pay attention or lock it down.
Yeah, I think it's a very interesting point, a kind of important one you mentioned there about it all being about risk appetite. Because like my background is in security. I've worked in security for somewhere over 20 years now. And the idea that something can be secure as a binary, just no, that's not true. It's what is your risk? What are you actually care about? How much are you doing with this? That's what's important. You can't, so if someone says to me, is this secure? It's like, well, I'm not answering that question because I don't know your threat model. I don't know your risks. I don't know what you're doing with it. Only after you know all those things can you say, yes, you've probably got the controls you need in place for that particular setup.
Yeah, security is a practice, just like cloud native is a practice and DevOps is a practice. Like you don't reach DevOps. It's like you're just, okay, what are we trying to do here? And we don't have an end goal. We want this to keep going on. And so if you're trying to be secure, you don't check all the boxes and say, good, we can give up. We can stop focusing on security now. Let's go to something else.
Yeah, absolutely.
Yeah, well, Victor put in here, anyone who has access to the cluster YAML files basically has access to everything. That's how it's currently set up.
That's at his company. And that, like, I know plenty of companies that do that. And that is just the risk factor and the trust. The risk factor is low and the trust is high. And that, like, hey, actually, we don't even need to audit the API server because I can turn to the people, in my office or whatever and say, hey, who did this? Right? Like that's the sort of trust you have. If that is the case, again, at my house, it's fine. It's just me. It doesn't matter. I know when it's, when something's happening. And so if that is the amount of trust you have and the risk is low, then I think that's fine, right? It doesn't have to be some other, OIDC flow to like get authentication and make sure everything's like, that's okay if your risk is low.
Yeah. Does that start affecting, so if they have a situation like that, or an environment like that, Justin, does that start affecting would that affect their SOC 2 compliance at all, if that's something they were going for, that organization needed?
I mean, it can, if you have like regulations bring in a whole set of requirements, right? Like the regulated environments have a specific set of, we don't like the regulations are mostly about like building trust with the company to say, hey, I believe that you don't have plain text secrets or easy to determine secrets, stuff like that. Like your password should have some length, right? Like, all those things are what regulations are bringing in so that external people can also trust the company. Because we know that there are some good practices around how this stuff works and how to verify if something is done in a way that we think is quote unquote correct, or at least some level of security. So yeah, regulation is mostly about letting external people trust what's going on internally and saying, oh, if you have your SOC 2 compliance, I can believe that you do this baseline of things, right? And when you get audited, if you're not doing those things, then you have to write a report or you have to fix it, right? And those are like the things that you have to solve. And so once you have those things and you say, cool, you're regulated or meet some certification, I can trust you with my version of trust of certification for a third party or using your service.
Okay, yeah, Victor followed on. He said in the past, somebody actually deleted a resource from the cluster. Yeah.
And that's a risk that you know, like it's a trade-off of time to set it up and maintain certain things and audit things versus when someone deleted something from the cluster, did your company lose money? Was there a big outage? What was the recourse of that action happening?
Mhm.
And if it was still low, if you say like, oh, actually nothing big happened, we just had to fix it. Like, okay, well then that's maybe the right risk level for you, right? Like I had my very first Kubernetes cluster, all the certs expired. Like I didn't rotate the certs. It wasn't something that like I know rotating certificates is best practice. It was a small cluster. There was 2 admins, me and one other person on it. Certs expired. People couldn't deploy applications for, I don't know, a couple hours. And it was fine. Like everything was still there. It was still running. We were still okay. But there are those risks involved. It's like, okay, if nothing bad actually came from it, then you're probably at this is okay. As long as you're, within some bounds of, not catastrophically killing the company or leaking information.
Yeah.
I think Rory brought up a great point though, is like once people say multi-tenancy or hard tenancy inside of Kubernetes, like a single cluster, that's when you're just like, if you're trying to do something like that, you definitely have to have a lot of trust, and the trust isn't inherent. Like you need to set guardrails.
It's a tricky game to play, and Kubernetes, in my opinion anyway, isn't really designed for that kind of use case. So you really have to kind of batter Kubernetes into shape to make it do it. It didn't come that way out of the box for sure. There's just too many ways you can leak information or you can get access across from one area to another. And that's kind of in the design of Kubernetes.
So we do have a question out here from Dan. How do you recommend deploying secrets for applications, pods? Oh, thank you, Justin. There you go. There you go. Knowing that they get mounted to the file
Well, you can
system.
still read it. It's still great to read it because people just listen to it sometimes. So
okay,
yeah,
so
I bring it into the video.
File system for the life of the pod. There you go.
I think the thing about that is that it depends on access to the pod, right? If you think about it, containers are just processes. So a process needs access to data. You either put it in the file system or you put it in the environment. That's where the process is going to pick up a secret. The key to being happy with the security of that is saying what things can read that environment or that file. Am I comfortable that I've locked down that access? So I've locked down, for example, people's access to run commands inside pods. That might be one way you get better assurance over the, how you're happy with how that secret's managed. But ultimately, secrets is one of these turtles all the way down problem. They've got to be in the clear somewhere for the application to use them. Otherwise, they don't do anything. And I just have an encrypted block. So either you can make that better by doing something like putting it in a KMS and sort of like encrypted key store when it's at rest. You can do things like, making sure they're audited so you know where they went, how they went, but ultimately you need to give your applications access to them. Whether that's Kubernetes secrets or an external solution, one of those is going to need to be used.
And I usually think of it as like, how did you secure secrets outside of Kubernetes? Like, what did you do before? Yeah. And if depending on again, your risk profile and trust, if having a text file on disk that only certain people could read or only on certain systems was adequate before, like, are you changing the model now because you need to make sure that the rules are the same for what they would have been outside of Kubernetes? And like Rory said, environment variables and text files are kind of the traditional way of doing it. External KMS, something like vaults or some identity system based on like IAM or whatever. There are all ways to give you access and to kind of put secrets outside of the application, because you can do a bunch of stuff with IAM that a secret's never on disk, but then anything that runs alongside that inside the pod with a process then also has access to the same API endpoints or whatever. So IAM is also difficult. So it's all trade-offs on how you're going to move this stuff around and where you're going to actually put the effort to keep secrets. I would say that secrets are one of those things that usually need to be rotated and audited. So putting them in some centrally managed place is often a good thing to have.
Okay. Got a question here from Daniel. I presume legacy security SaaS services would be moving security north to eBPF. Is that actually happening?
I think eBPF is a really interesting technology to me. It's obviously very useful, but fundamentally what it is a thing that allows you to run programs safely in the kernel. That's what eBPF is. How you use it then is how anyone uses any feature. It has advantages, obviously. It has deep kernel visibility. If I run an eBPF program, I can see right into the Linux kernel. I can grab things at a very low level. But it has consequences. How do I then tie that together with higher level data? Right. So yes, I think people are doing it. It's got better performance. And it's got visibility advantages. But I think there are challenges in eBPF, as with any technology. It needs work. And we're seeing more and more companies do that, just mainly for the performance benefits, I think.
I think the ecosystem around eBPF needs to mature. There's a lot of things that people are throwing these binaries into the kernel and saying like, this is going to be better. And then when they try to trace them or debug them in some way, or like, actually, this is really difficult. And so the overlap of what's running in eBPF, I like that it is currently fairly narrow scoped, but I do agree that it's the interface that a lot of people want to be in for things like high performance networking and security auditing.
I think you're right. That's a really great point about visibility, because I've done a little bit looking into, and one of the things, for example, some CNIs in Kubernetes will move all of the rules into eBPF programs and out of IP tables. Yes, but I could look at IP tables using a user space tool very easily. Can I do the same thing for eBPF program? Potentially, but maybe not. Maybe it's not as easy. So
there
yeah,
are some, some tools are coming along, but it's not nearly as mature as traditional tooling in this space.
Yeah, I know. I think that aspect of like traditional tooling and being able to use things, because that's a real strength of Kubernetes and containers, is that they are Linux processes. And therefore, fundamentally, I can use Linux tooling that's very mature, there's lots of it, to look at them and introspect and work out what's going on. And as soon as you move to a different technology, you lose all of that great tooling, which makes things harder. It's one of my personal pet hates is gRPC interfaces, because I like HTTP tooling. I used to be a pen tester. I used to do stuff with curl and everything. And I like to be able to like interact with things using those tools. As soon as you go to gRPC, it's like, nope, you need a whole different set of tools which are less mature.
As a company that builds gRPC APIs, I 100% agree with you that gRPC is a great technology, but it is hard for other people to kind of build around it and to understand it, and the ecosystem of tooling to build on top of it just isn't there. It's mostly just a Go language thing, right? Like it's even hard to do in other languages, right? As soon as you start to go to Python or something else, you're like, oh, actually, this support just isn't here.
Yeah, I think that's so it's one of these things. I think we always come to this point of it's kind of a trade-off. eBPF has definitely got its use cases, and I think we're definitely seeing it in security agents for like low-level visibility.
Which also many people mistake that non-visibility for security, right? That's also a thing that I see over and over again. We're like, oh, it's eBPF, so it's more secure. I'm like, wait a minute. Like this is just, like, yeah, it does compile to a subset of things that it can do, but if you can't poke at it and you can't see what's actually happening, then you're just not paying attention and you don't know for sure if it's secure or not. So there are definitely things that I would like to see more of in the space to be able to verify some of this stuff. And again, that's just ecosystem building and kind of time for adoption.
Mm-hmm. For sure. Well, we have a question here. It's a long one from GJ, and I'll go ahead. Basically, he wants to know if Datadog and Talos Linux work together. How did Rory come to this podcast? So maybe we can cover that really quickly, Justin.
Rory, you were recommended to me from someone else that I know in the Kubernetes space doing security stuff. And I had seen your talks before in the past, your 4 CVEs that are unpatchable. I remember watching that a while ago, and I was like, oh, this is amazing. And so, yeah, when someone else also recommended you to come on the show, this wasn't a specific Datadog Cedero thing. This was a general security sort of Kubernetes thing.
And that's, from my perspective. So while I work in Datadog, I do a lot of work in the community. So I'm on the advocacy team. So I tend to work less on the product side and more on the kind of helping the community and working on security. And so that's, for a while. I've been doing Kubernetes security. So I do put in before I talk to this, coming from 10 years now. So it's been a little while. It doesn't feel like 10 years. But it is. But the point about Datadog, I think that's one I definitely off the top of my head couldn't answer. Datadog obviously looks to try and work and have our agents work. But again, it comes down to distribution support. There's 150 distributions. You have to do some work with each one in order to get things kind of sorted out and working. Yeah,
and the last time I was trying to run Datadog, there were things that the Helm chart was doing, trying to mount into Datadog that don't exist on Talos, like a Etsy password file, right? That this just doesn't exist on Talos, and Datadog wanted to mount it and verify users. And it's like, yeah, no, it doesn't exist. So the Helm chart failed. So you had to fork the official Helm chart to be able to like remove mount points that again don't exist on Talos or are read only.
I think that is, when this comes back to the point we've kind of made a couple of times, is how flexible this whole ecosystem is it's really hard to make assumptions about where things are going to be, paths, mounts, and everything else. One of the things I help out with is the CIS benchmarks. And we have the same problem, right? You write a CIS benchmark rule, and I'm trying to write a rule that's going to apply to everyone. I'm like, that's not going to work, because Talos is different from Rancher, which is different from OpenShift, which is different from, you know, wherever else. And so that flexibility is great, but definitely has serious costs when it comes to things like that. Whether you want to work across the whole piece.
And I mean, to that point, GJ, like the main problem we have with Talos in general is just that security tools don't work with it, because they all make assumptions about what access they have to the system and what exists on the system. And those two things, like Talos doesn't have a bunch of mount points and all of it is read only, and binaries don't exist. And so a lot of the security agents that people are trying to bolt on to say we need to make sure this is secure, they don't work, because those systems assume they can own everything on the box, and we don't allow anything to do that. So that is one of those things that it's not a Datadog problem. This is just like, in general purpose Linux distros have a bunch of stuff, and we don't. And Rory, as you're saying, like, who builds a Linux kernel from scratch? It's like, we do. Like, we literally, like, every release is like built. I haven't built a Linux kernel this many times since college, and it's been great. I was like, it's been having fun. I was like, oh, cool, I get to build the kernel again, and we make it easy to do that, but we minimize it as much as possible. But in those cases, like, we're building this from source and leaving out, we're not taking Ubuntu and cutting it down. And all those assumptions now go out the window when, how do I call systemd? I'm like, well, we don't have systemd. How do I do these other things? We just don't have them. And so all of those assumptions are going out by just saying, hey, we make a single purpose thing. Now we're not trying to bolt on security in the general purpose ways. So we've been working with some of the vendors. Some of them have been very receptive on how to make that work, just to be able to give some of the auditing features, not necessarily the hardening features. We try to make it as hardened as possible out of the box, but being able to verify it is a thing that everyone does need. And so we're building some of that in. Like, we had SBOMs released last month with Talos 111. You can verify all the CVEs through the SBOMs, right? Like, it's, hey, oh, cool, I can now see this side of it. But for agents and ongoing and runtime sort of stuff, verification, that's still a process that we're kind of working with folks on, saying this is a different model.
Interestingly, I was actually, I was obviously, when I was getting ready for the webinar, I was looking at Talos and like using Talos Cattle to like spin up clusters. And one of the things that was very useful to me, because that Talos Cattle spins up in Docker, you can then go through standard Linux tools. So, you know, find it in proc, find it in the proc file system, and then go, okay, I want to go and see this file, but I know that you're locked down, so I can't just like SSH into the node. That's not going to work. Okay, cool. It's a Linux file somewhere. Look inside the namespace, look inside how, you know, that's mounted, and then go down from there. Which is, again, probably my favorite feiter of containers, is the fact you can do that. You can go around.
Yeah, once you know how a container in a C group works, like it always reminds me of the Jurassic Park scene when she like goes up to the computer, she's like, oh, this is Unix, I know this, right? And like, that's the eye-opening piece for a lot of people, is they're like, oh, this is just Linux file system. Like, if you learned how the Linux file system works, which is difficult. I'm not saying everyone needs to know that. I'm not saying it's a general knowledge thing, but once you understand that, like, the containers are just repackaging of that sort of model, it's like, oh, I actually can debug this with tools that I know how to use.
Yeah. I mean, things like learning a little bit about namespaces, learning a little bit about capabilities, that's all good foundational Linux knowledge, but it really helps when you're doing containers. And I've done a couple of training, and that's one of the first things I try and get people to learn. Is like, here's how namespace works. Here's that, and if you know that, then you know a lot about what containers are doing and how they're doing it.
Well, here we have a very specific use case question from Andreas. Company, they're mature in their Kubernetes, nodes on private endpoints, security context is in order, filtered their capabilities, added a seccomp profile, workloads are running with separate service accounts, namespace to namespace, network policies. What's your advice for the next step? Did they overlook anything?
I can say one they've not mentioned, which is one I always mention, which is turn on audit logging. Turn on Kubernetes audit logging, because if you don't, you're potentially missing critical security information. You know, you've locked it down, but what if an attacker could get to the API server? One of the things you can do in Kubernetes, if you can get to the API server, is you can create client certificate credentials, which last for years and can be high privileged. The only way you will spot that is having audit logging turned on and looking for that event. So that don't neglect I know hardening is great. We like hardening, we love it, but don't neglect auditing and monitoring, because they're still needed. So that's the only one. I mean, you may have that as well. Couldn't fit it in the question, but that's one that jumps out to me.
Yeah, and I mean, for next steps, like my opinion, usually just like, well, what are you doing? Like, what are you trying to do? Like, is this a multi-tenant, you know, public, anyone in the world runs code in this cluster sort of thing? Like, there's a lot of things you might be doing at like a runtime. Do you need gvisor? Do you need, you know, some container isolation on a single node? Like, all of those things are questions that I would have, like, depending on how you're using what you're doing in the workloads. And most people right now are like, well, we're trying to do AI, right? We have some GPUs and we're doing all this stuff. It's like, okay, well then how are you securing the GPUs? Because GPUs don't have the same style of hardening and isolation that CPUs have. And so we can't say GPUs are multi-tenant because they're not in a lot of ways. And if you're depending on the hardware you're using and the drivers and all this stuff, it gets really deep really fast on what are you trying to do and what are you trying to do next to know what should you be looking at.
Yeah, I think the AI point's an interesting one actually, because obviously a lot of kind of tech press is very focused on AI and LLMs at the moment. But when you look at the companies and how they're doing it, something like Kubernetes really fits their use case, because that whole concept of bursty workloads is like, well, that's exactly what Kubernetes is made for. Having specific actor hardware, yep, that sounds like Kubernetes as well. So a lot of these people are actually building on Kubernetes. So even if it's not being quite as talked about, it's under the covers in all of these organizations. So just fun.
And then here's and Jose and George's, I'm not ignoring you, but there was another use case here Yannick shared. They recently moved from Kate's Ingress to Gateway API to make external communication possible. We went for node port services. Our worker nodes have external LB in front and are not accessible from the internet itself. Is there anything additionally we can do to increase security? And somebody else mentioned Notary, so just letting you know. We got the community jumping in and helping out.
Thanks.
That's an interesting question. I mean, it's again, this comes back to I think what Justin was talking about the last one, is it depends on what you're trying to do. That sounds like a sensible approach, Gateway API being the modern way to handling ingress, and locking down where you can get access from a networking standpoint. That's pretty much where I always go to, is trying to lock down who can see things. Whether you need, for example, something like service mesh, maybe service mesh is needed in that case. You know, you need encryption of the traffic going across the wire. Maybe you don't. That's going to come down to your use cases. So it depends, like everything with security.
Yeah, I would say that one misconception I usually like to clear up is like everything is a node port. I feel like in Kubernetes land, we call it different things like a load balancer service or node port or various things. Like every service you expose mounts a port on the host to a pod internally. And that's node port stops there. And node port's just like, okay, I got this port and you do whatever you want externally with that. If you're doing a load balancer service, it takes a port on the host and it maps it to a pod internally. And then it also puts something in front of it and says, okay, you can route to this port. And that's like, every time people are like, oh, I have all these different services or I need these, like, no, it's all ports. Like the only way Linux exposes something to the network is via a port. And so every type of Kubernetes service is just a port. And we just have different terms for that in Kubernetes. So just FYI, like it's not inherently less secure or something. It's a little more manual for you to do. How am I exposing this port to the rest of the world? And so, yeah, just clarifying that, because that was always, again, one of those eye-opening things for me when I was running my first Kubernetes cluster and I just do like, you know, SS and I'm like, oh, these are the open ports. It's just open ports. Like everything is a port. Okay. Now we understand again that the fundamentals of Linux haven't changed with Kubernetes. It's opening up a port to the network that routes into some process in Linux, and that's it.
Yeah. It's funny you mentioned like that, looking at fundamentals and it all being Linux. One of the things that I always like to talk about networking is the fact that service objects are IP tables rules. Yeah. So you create a Kubernetes service object, what you're actually doing is creating an IP tables rule. IP tables have been around for at least 25 years, but that's what it is. You just don't need to concern yourself with exactly what that rule looks like. You define something higher level. But if you actually go to the node and go IP tables -L, it's like, whoa, there's a load of rules there. And that's what services are. And
in Talos, it's all NF tables now.
Yeah,
so Kubernetes in general moved forward, and yeah, we were moving with
slowly. And it's like, yeah, I mean, it's interesting to see how that changes, because I think with IP tables, there's so much inertia essentially, or things written around the assumption. We talked before about assumptions about what things provide. If you assume IP tables and then suddenly it's not there, hopefully everything's fine. But it can be interesting to see that transfer as Kubernetes kind of moves away onto NF tables.
I've been very fascinated on just generally how backwards compatibility with things like IP tables and things like, sysvinit sort of thing, like systemd still, if you drop something in the like etc and initd folder, like systemd often like converts that, the fs tab, right? Like it converts that automatically to mount services or mount objects or whatever they're called in systemd now. So it's like, it's backwards compatible with like, yeah, you can just write it in fs tab. But it's not the way you shouldn't be doing that today. Like you should not be modifying FS tab anymore. You should be writing systemd mount units. But the backwards compatibility, because the assumption is there that this is going to work for some amount of time. And IP tables are a very similar use case where it's like, yeah, NF tables has to keep some compatibility with it.
Yeah, sure.
We have kind of a specific Talos question here for you, Justin. Are you updating is that STIG or STIG?
Yeah, the STIGs. Yeah. We definitely need to. The STIGs there have not been updated for a while. We're looking at it. If you have specific requirements, please email us. There's plenty of forums on the websites to contact us on what you're looking for. We are looking into what that would look like next year to be able to update that. So to make it also much more complete, because right now it's a very limited set of what gets tested.
I'll actually make, if it's okay, I'll make a general point about kind of configuration standards and external standards in Kubernetes in general, because it's a really tricky area. Things like STIGs are great, but you do have to watch in general how updated they are, because the governments and agencies like that don't always keep things fully maintained.
Yep.
Even things like the CIS benchmark, I help out there, and it's a struggle because you have to come back and actually try and maintain it. And now there's a suite of them in CIS. So you need to be quite careful. And again, that they are actually being maintained, because Kubernetes, as we all know, changes 3 times a year, and things do change. And if you get something from 2 years ago, probably, it doesn't mention validating admission policy would be one example, because that didn't exist 2 years ago. So there's that aspect of being careful in general with your standards.
Yeah, it's definitely a baseline, right? It's not a target. It's like, hey, this was created, and if you have ever gone through any process of making some standard, it takes a long time, and by the time you're done with it, it's outdated. And so anyone that's consuming it after the fact needs to know that and say, okay, what else has changed since then? And it's incredibly difficult to find some documented, here's the latest and greatest up to date way of hardening things.
And the point, because we've made this point now several times, that it's all about risk, right? It's not one size fits all. But standards are, by their definition, one size fits all. They have little checkboxes that go pass fail. And you can understand that can't be right, because the standard writer, they didn't know you. They didn't know your cluster. They didn't know your business. They just had to, and I've written a couple of these. You just have to go, well, this is kind of right. And, let's give you as much context as we can. But yeah, don't ever take them as being like, I need to have 100% on this thing, because it almost inevitably won't be right. You'll either, in the early as a CIS, we said if you make yourself fully compliant, you break your cluster. Change that now, so it doesn't do that anymore. But it's very easy. It's not applicable to you. You do have to use them as a starting point.
Yeah.
Okay, Marco, over the last upgrades, looks like Flannel is heavily preferred. Shouldn't Cilium be a more secure choice as an open source option?
I'm assuming you're meaning specifically with Talos, and in Talos, I think we only have Flannel as a CNI that we include, mainly just because it's one of the simplest, and it just works in most cases, right? Like it doesn't have a lot of knobs, and it doesn't have a lot of configuration, and we like that because it works in most cases, because there's always this balance between onboarding and user experience and actually like production grade hardening and feature sets. And that's, I think, most of the concerns here with Kubernetes, with Linux, it all comes down to that, right? Because if you had to spend 2 weeks to harden a Kubernetes cluster before you could use it, absolutely nobody would use it, right? You need to be able to ease people into this and help them learn on their own and figure out what they actually need. And so Talos by default provides a Flannel install that we know works in most scenarios, but it doesn't have all the options of Flannel. It doesn't let you configure everything in Flannel, and we make it as easy as possible to replace it by just saying, yeah, I don't want a CNI, and you can bring whatever one you want. We know a lot of people that do Cilium with Talos, but we don't put that in there. One, because Cilium's a big application. Like it's more than a CNI. Like there's a lot of things about Cilium that happens that some of that configuration also conflicts with what Talos does. Things like node to node WireGuard tunneling. that breaks if you're using something like Kubespan that Talos provides. There's a node level firewall that breaks if you're using the Talos level node level firewall. So there's things that are features in Cilium that aren't necessarily more secure. There's more features that you can enable, and we don't know how everyone wants those configured. And our default, if we ever do a default Cilium install, is not going to let you tweak most of those settings. It's going to be a very baseline. This works in most cases. But as we were saying earlier, Cilium's kind of hard to debug. Right? Like there's the eBPF programs make it a little more difficult to expose some of that and understand what's actually happening here. How is this actually working? Flannel, I wouldn't say is the easiest thing to debug, but it is a little more standard in how it's doing some of the encapsulation for packets. So that's kind of the, like, Flannel's always been there in Talos since the beginning, just because of the simplicity. We know it doesn't have things like network policy, which should be something a CNI has by defaults. And I don't think Flannel's ever going to get it now that it's, you know, it's a CNCF project, but Weaveworks, the main company behind it, isn't around anymore. So we're looking at what else we might want to do, but we want to keep something as simple as possible with a minimal set of features that we can provide. Maybe Cilium comes in the future. One other blocker we had for for Cilium specifically is it requires Helm. Like the default install for Cilium is a Helm install, even if you're doing like their CNI or their CLI Cilium command, it's still like templates out a Helm file, and we don't have Helm embedded in Talos anywhere. So if we want to do that, we got to bring all of Helm into Talos to be able to do this stuff, and that was kind of a thing that we just didn't want to do. So again, there's reasons for it. Flannel's just always been there. It's a simple thing that works, but it's absolutely replaceable. And if you're doing something at like production grade or you need network policies or whatever, you probably want to swap it out to for something else.
Okay. Jose needs a little bit of advice here. He needs help activating hardening standards.
Well, I mean, I think for me, anyway, this one comes down to what we were talking about before, is those are a starting place. And I know that's difficult because if you've got a compliance or auditing team, they might be saying, no, we need you to comply with these things. But it is very much about looking through and saying, right, you know, what do I actually want? And then you might have to write up justification documents for your auditors to say, we didn't do this because X. But I think that's, for me, where you would always end up having to go. It's tricky to say. I don't think there's many places that could say, I just want to like slap this on, and that's definitely going to fit me.
One thing that we see a lot with Talos is the amount of people that just have checkboxes that said it doesn't apply. there's so many of those boxes that they're going through some hardening guide or some other security audit, and they're just like, actually, it's a read-only file system that runs entirely in RAM. 80% of the baseline like Linux hardening just doesn't apply anymore. You can't apply it because it's like you have to build your own custom distribution of it, and we try to harden it by default. So that sort of stuff. Like if you need the KSPP hardening for the kernel, Talos does it by default. Right? Like you don't have to go through that process. Like I need to harden my kernel based on this standard. It's like, well, no, we did that. It's fine. Like you can just skip that whole step. So there's those sorts of things that, again, we try to make it as, excuse me, as secure as possible out of the box, but also as practical for people to use, because there is that balance always of, I can make something entirely secure that no one can use. But at some point it has to do some work for you.
Well, I was
Thanks everyone for all the questions. This has been like super interactive and I love it.
Yeah, it had. I know. I love all the questions, and it really what's kind of coming to mind. And this is the question from I'm going to say Georges. Not sure if I said that correct, but people are craving information. So let's talk about some online communities.
I can give you one, which is there's a Kubernetes has, if people who don't know the project, they're split up into SIGs. So there's different special interest groups, and there is a special interest group for security. So Kubernetes SIG security, there's a channel on Kubernetes Slack, and we do meet every other week. And we've got a number of sub-projects. We're looking at different things, but we tend to also talk generally about Kubernetes security. And there is another Slack channel on Kubernetes Slack called Kubernetes Security. So if you have questions about Kubernetes security, that's not a bad place, because there's quite a few people who are interested in that topic who tend to hang out in that Slack. So that's one I would definitely mention. I
think a lot of the communities also kind of focus on use cases or tools too, where it's like, oh, we have a tool that we really like, and that tool probably does some security stuff, and they have a great community around it, like Falco. Right? Falco is a very specific security tool that has a community around it, and I'm sure they have their own Slack channels and places that they hang out. That if you want to use Falco and are interested in that security, go check out that tool and that community.
Yeah, for sure.
Here we go. We get to go to Cluster API. What's your opinion on tools such as Cluster API or Crossplane from a security standpoint? Is it possible to configure a Talos Linux machine using Cluster API?
I'll take that one. Those tools are generally provisioning tools that need a lot of access to a lot of things. You have to be able, just like Terraform, right? Like we just look at Terraform. What was before Terraform was Bash scripts and Bodo 3. There's all these tools that we've had in the past that all did roughly the same thing, where at the end of the day, they want to call infrastructure APIs and create something in the infrastructure. How do you secure those tools? How have you traditionally secured those tools? And traditionally it used to be like, there was an environment variable or password that everyone shared that had access to do the thing. And that moved into like Jenkins. And we say, oh, now we're running Terraform in Jenkins or in GitHub Actions or whatever. There's a secret on the repo that is write only. No one else can read it, right? So we can append, we can write and replace it, but no one can pull it out because that's how we want that security aspect to be handled. Crossplane, all these other Cluster API, they're all roughly the same thing, where at the end of the day, they need some secret to call an API to do something. They have a lot of access. They generally need something like admin system level access to be able to call and create whatever they want in that environment. And one of the things that I learned at working at Amazon was everyone at Amazon had their own AWS accounts and we were all admins in them. And then once we went to go talk to customers, none of them had admin access. And it was just like a very different thing of like, oh, well, why don't you just make this CloudFormation stack? And like, because that CloudFormation stack has 4 different teams. Right? Like I can't create the one thing because this team has access to that team has access to this. And as you granularly break down that access, it gets much more difficult to automate some of that stuff because you have to tie it together in a people process, not in a technology process. So things like Cluster API and Crossplane are really easy when you just give them all the access in the world, just like Jenkins and just like anything else that generally likes to do what it wants. But historically, those single points of full access have been the targets for malicious actors. And like Jenkins for a decade was always the first thing that that always got compromised in the environment because it was the thing that had secrets for everything. And so unless you're securing and auditing and know how to manage those secrets in a very secure way, it's going to be an attack vector for someone. And so just historically, that's how this has happened. That's how I think that's happening in the future. And a lot of people, they just drop in Crossplane and they put a Kubernetes secret in there, not an external secret manager. And it's just like, it's a base 64 encoded string and anyone can see that if they do, if they're in that cluster. So be careful with those things. If you're looking at hardening stuff and then centralizing that, because the more you centralize it, the more it's an attack vector, the more access and resources it needs. If you try to split it up into separate teams, into smaller pockets of access, it becomes harder to manage.
I think, yeah, for me, there's a couple of points of it. On the one hand, I like things like Cluster API because I'm a favor of larger numbers of smaller clusters and anything that makes that more possible. Because blast radius in big clusters is one of the things I think concerns me with very large multi-tenant clusters. On the other hand, just as Justin's saying, it's an additional layer of complexity. It's more points of access, and it's a very high privilege place. So you have to be very, very careful if you're going to use those kind of tools, that you are being very careful. And we're seeing this because, you know, you're saying Jenkins before, now people are moving to GitHub because GitHub and CI/CD are now the new places where a lot of people have got all their secrets and can do things. And guess what? The attackers worked that one out, and they're going there too. So anywhere you're going to introduce that's going to have great levels of access, you need to be thinking very carefully about how you kind of lock it down and secure it.
And I'm not saying that like anything else solves this well. I don't think even in Omni, like we have a way to provision infrastructure with infrastructure providers that is a separate binary that exists. It still connects into Omni to get secrets to be able to call some of these APIs. But like that is it's a model that I don't think solves the problem perfectly. Like in some way, you just need to be able to audit where are my secrets, how are they maintained, who has access to them, how is it audited, and that is a practice, not a architecture. And you just need to be able to know how to do that to be able to verify stuff is working. So I'm not saying that like Crossplane and Cluster API aren't, you know, cool tools that do a lot of stuff and can be used in a secure way. But it again comes back to that like trust and risk aspects.
Yeah, and I think it's an important point you mentioned because it's one that I think, coming from a security background, it's definitely something that was in my kind of like work ethic, which is around auditing access, saying, well, you know, hey, we've had this for a while, for 6 months. Who's got access? Do they still need the access they've got? Because we used to do access audits and find regularly people had left the company, they'd moved teams, they'd moved roles, that application had changed and wasn't needed anymore, but the access tends to stay. And so you do need to like think, hey, I'm going to go through and check and make sure everyone still needs all that, and the credentials are still what's needed as well.
Okay. I just want to give a shout out to Jose. This is the previous question, kind of jumped in there, sharing a little bit about Open Policy Agent and Kyverno. I don't know if either one of you have anything you want to add on to what Jose shared.
I'll mention one thing, which is, this is one of those things about staying on top of Kubernetes, is that Op and Kyverno are great tools. If you want something inbuilt, then validating admission policies is now GA. And that can do not everything that they can do, for sure. They've got more functionality. But if you have quite a basic set of use cases, like, for example, enforcing pod security standards, validating admission policy is a great option for that because it's internal to Kubernetes. You don't need to install and maintain and manage access to an external system. And as we've kind of mentioned a couple of times now, every piece of software you add to your environment is something you have to maintain and secure. So if you can get by with inbuilt Kubernetes functionality, I would say it's well worth looking at.
And even just moving from the OPA Rego language, Rego, whatever, into Q, right, which is what the built-in validators use, is very different. And I, from what I've heard, a lot of people like Q much. It's much more simple. Because it's doesn't do everything, because it's a very specific use case. You can audit it a lot better and write it a lot better than what you were doing with the older Rego rules, which had all the flexibility in the world because they could do everything. And now we're like, actually, in just this use case, we can use a different language that is easier for us to maintain.
Yeah, Rego's, I think that because it's a kind of slightly different language, it's just a kind of mindset switch. And I know people who write a lot of it, they can get into the habit and it's great. But if you don't do it very often, it's kind of funny language, I think, to get your head around.
I mean, it's all going to come down to which one can you vibe code more, right? Like,
yeah. I have found LLMs are not bad at Rego, or Rego, how you pronounce it. Yeah. They're actually not bad at creating at least basic policies, for sure.
Yeah, they're amazing at Bash. Pretty much all of the LLMs are just like, oh, there's so much Bash examples out there. It's like, cool, this is the boilerplate that I used to maintain myself. I don't need to anymore.
We have another specific Talos question, Talos Linux question. If you run it on EC2, does it replace the AMI altogether? Justin.
How are you getting it into EC2? Like usually you would use an AMI that's published, or you create one. Like we have one that we publish that is out there and available in AWS. It's not in the marketplace because the marketplace requires SSH keys and Talos doesn't have SSH. So we have no SSH keys. So again, one of those security like best practices that just don't apply in our case. So we can't be in the marketplace because one of their requirements is what are some defaults on passwords or SSH keys. Like, hey, we don't have passwords and we don't have SSH keys. Sorry. But you need an AMI out there in AWS to like create the EC2 instance. We have one we publish, or you can create one and publish it yourself. You can like take a different like Ubuntu system and like replace it with Talos, but I don't recommend that. There's some people in the community that also like started doing that, and it was fascinating to see they were replacing systems in place with another Linux distro with Talos. But once you try to like, if you're in an auto scaling group and you say spin up another one, like the old AMI is going to come in, it's going to be whatever it used to be. So you want a Talos based AMI. I think you might be also talking about upgrades. And when you upgrade Talos from one to another, you don't need to replace the instance because you're replacing on disk what's booting. So it's going to switch the boot partition. It's going to boot to a new version of Talos without replacing the EC2 instance, which is something that at certain scales is super valuable because it's faster. If you need to go create another EC2 instance, that's AWS calls, EBS volumes, networks, ENIs, all this stuff. If you already have an EC2 instance and you just need it upgraded, Talos will do an upgrade in place a lot faster than a new EC2 provisioned. So that's one of those benefits. If you're doing Talos upgrades, it's immutable at the OS layer, and you don't need to create new VMs, which is again one of those things that like downsides of how something like Cluster API works. Cluster API always assumes it's going to replace that VM with a brand new VM every time. And we don't have to do that because that takes more work. You need extra resources. You need to scale up all this stuff. We can replace this VM with this VM and just keep it in place. And that stuff just happens faster because it does it at the file system layer and just does a reboot, does a kexec actually. So it doesn't even go all the way down. It's just like, okay, new kernel. Now we boot up and we're ready to go.
Okay. This is a good one. Here you go. Do you mind giving a quick run? I don't know if there is such a thing as a quick rundown on validating a mission, but I guess I'm going to learn right now.
I can try and give it a little bit of overview. So essentially, the idea of validating admission policy was to provide a flexible way of having policy language inside the cluster. There's two features. There's validating admission policy, which is GA now, I think, for a couple of versions. There's also mutating admission policy, which lets you actually change workloads or change manifest as they're put in. And the idea is it works in a way very similar to something like Kyverno, where a pod is going in through pipeline, it passes authentication or authorization, it gets to admission control, and then it hits policies that you define. And they're fairly flexible, and you can define them in either like a warning mode or an audit mode or an enforcing mode. By the way, always start with warning or audit. Do not start with enforcing unless you like breaking people's things. And then
Talos has a default PSA for enforcing for everything outside of the Cube system namespace, so that it's not privileged. So you can't run privileged pods. So it's an often thing that people come to Talos clusters and they say, I can't run my workload. I'm like, yeah, because you didn't define these 5 best practices that say don't run as root, don't allow privilege, don't mount the host file system. I forget the other ones, but like you need to define those. And almost all of the Helm charts publicly available, even if they don't need it, they don't define that. And so we block it by default. And so if you are running something, you have to either turn off PSAs for that namespace, or you have to change the Helm chart. It is a friction a lot of people have with Talos clusters. But again, secure by default. We want you to have some baseline that we would trust to put out there.
And it's actually a really good point, because that was actually worth mentioning as well, is there's now essentially 2 mechanisms for doing this in Kubernetes. There's pod security admission, which is nice, but not totally flexible. Like you can't say, actually, you know what, I kind of need in this one namespace, this one thing. You can only define the 3 levels. And then that is kind of like the newer one, validated admission policy, and it's much more flexible. So you can say, you know what, I want this, this, this. I also want some other policies that meet my specific requirements. And you can kind of work off any part of the spec in a manifest. You can say, I need this field to have this kind of value to validate. So it's useful. I will say it's still fairly new, and there aren't a huge number of examples of like good validated admission policies out there. But I'm sure that'll develop as time goes by, as it becomes more used.
Okay.
Yeah, and I will say that in general, PSAs and all the features you're seeing kind of move into the Kubernetes, like API specific, like becoming GA now, were things that were common with external tools, right? The Kyvernos, the tools that were saying, hey, we just want to validate that no one's running as root. Like, oh, we can actually do that in the API. And even things like service mesh stuff. I remember back in the day, the main thing people wanted service mesh for was so that it would route traffic in the AZ they were in. Like, hey, I don't want cross AZ traffic if I can help it. That's built into services now, right? Like you can that's part of a service declaration in Kubernetes. So there's a lot of that stuff that used to be ecosystem things, but whatever was most common sometimes makes it back into Kubernetes. And it's just, actually, we don't need to run and maintain and build a third-party tool. We can build this part into the spec and have the controller do those 1 or 2 things. And in that case, it just makes it easier for a lot of people to do what they had to traditionally add a bunch of software for.
Okay, we probably have time for one more here. Here's a question from Marco. During CA rotation, some deployments break and need rollout. Is there a way to add some reboot to the CA rotation command?
I'm sure there's a way. I don't actually know specifics on the CA rotation flow today. I know we've been doing some work in that, and I don't know what state it's in. So I would open a GitHub discussion if you have a question. So on the Talos repo, go to GitHub discussions and ask there. Some of the devs would know for sure what the current state is, but we also want to get like what version you're running, Kubernetes versions, what Talos versions, that sort of stuff. So GitHub discussions are where we generally try to push people for those kind of questions, because the whole community benefits from it, right? If someone's not watching 58 minutes into the stream, they're not going to get that question. But if they go search it in GitHub, they can hopefully find the discussion and benefit.
Yeah, and then we also have a community Slack channel, and then on our website, we do have support and service options. I saw a lot of questions on security, so you can reach out and talk with somebody about your environment, and if it would help to get a little more guidance from our team. I cut you off, Rory. I want to let you finish up here. Go ahead.
Just something I was going to mention, because it's something that when you talk about GitHub and GitHub discussions, one of the things I'll say from my experience with Kubernetes is if you get into it and spend a lot of time, you'll become an expert at spelunking GitHub issues. Because there are a number of things in Kubernetes where the only way you're ever going to find out what the actual answer is go look in GitHub issues. Definitely a top tip. Try searching in there, because over 10 years, right? There's a lot of people with a lot of questions, and they're generally in there somewhere.
Okay. Well, and then yeah, I will just close and say we have GitHub discussions, we have Slack. Rory, how can somebody get a hold of you or talk about security in the Kubernetes community?
Fairly findable on all the socials. If you look on GitHub, my username is Racine, Raesene. I'll put it in chat. And typically that's my username on most places. So if you search for that, I'll probably show up somewhere.
Okay. Well, thank you everybody for joining. Yes, this will be recorded. This will go out on our YouTube channel, and we appreciate.
I mean, do we want to? We didn't mention TalosCon. I'm pushing the button just to say it's next week. I wanted to throw it out there. Is if you want to talk to more people using Talos in generally Kubernetes, TalosCon is next week. There's still tickets available, right, Kim?
Yep. Yes, sir.
Sweet.
Yeah.
So plenty of great talks and workshops and things coming up for it. So if you're in or around Amsterdam and want to come TalosCon, sign up there.
Yep. Thank you all.
That's all.
Thanks, everyone.
Cheers.